I'm now talking about limes, cements and plasters. When Europeans settled in Australia, lime was burnt locally, largely from shells from Aboriginal middens. The Aboriginals had left from their feasts whole piles of shells around the coast, and they were used for lime. Later on, limestone was more commonly used, and in some parts of northern Australia, coral was used. They all have the same process involved of using calcium carbonate to get lime. So in some of the early examples, we find this is mortar from an early brick from Tasmania, and the little bits of shell actually in the mortar, and that shows this was burnt from shell lime in those early days. Now, later on, some natural cements were found, which are rather stronger than lime and have some capacity to resist water, say water, rain and so on. And then much later on, Portland cement, which is the modern cement, was both imported from Britain and made in Australia, and that sets underwater and has very strong hydraulic capacities, can be used for harbour works and so on. But at first, you're coating a building in a material which would dissolve in the rain, so you tend to have not much ornament on the face of the building and a good coat of paint to protect it. This is an early example. It's a very primitive building because you can see these are the remains of timber saplings. So it's timber saplings on the outside of the building running horizontally, and then this on the face, smooth facing, which looks quite sophisticated when it's finished because it's been made totally smooth and ruled in lines to look like the joints in masonry. And that's the way lime is normally used, was to imitate a masonry building. And sometimes it's had a coloured wash, sort of brown or creamy coloured wash to enhance that effect. So you find on this primitive building that being done, but also on other buildings like this example here, which is from a building in New South Wales. Again, they were sapling and mud buildings, but rather more sophisticated than the one I just showed you. And then again also, this which has been on a same effect, a ruled line. The lines can be ruled either with just a groove or with a crayon in them, or both. But this one has been on brick, as we can see the shape of the brick. So the same system is being used for all sorts of different wall finishes to give it the appearance of stone. Now here's an example of a primitive form of concrete, quite strong. It's from a butter factory in Gippsland, and you can see in here all the local pebbles, some river-worn pebbles, local materials. Smooth pebbles are not desirable for concrete. It's better to have sharp, broken stone than these smooth ones, but this is nevertheless pretty strong. In this case though, unusual detail here, on this side, what appears to be some sort of burnt cork material. And this is because it was a butter factory, and this was the insulation in the walls of the factory. Now, when you come to true concrete, it's a material, of course, very strong like this. This is a core sample, which will be taken by an engineer, and it cuts right through all the aggregate, the stones inside it, which are, as I said, sharp stones in this case. Usually when we're investigating buildings for historical purposes, we're not so concerned to get a sample like this, which can be to standard size, can be tested for strength, but to get the details of these stones and the content of the material. So we find rather different components. This here, for example, is a cement render. There's the face of the building has this pink paint on it. Behind it is a sort of layer of cement and possibly plaster, and it contains within it hairs. Commonly on the face of a building, and in fact on internal plastering as well, you would add either animal hair, like horsehair and so on, or occasionally some other material like straw into the plaster to reinforce it. Many buildings were made of solid concrete. So in the 19th century, when you speak about a concrete building, you're not assuming reinforced concrete as you would today. It can be just solid lime concrete. But here's a variation. This material here contains coke breeze. So it's a concrete, but instead of having stone like basalt chips in it, this is coke breeze, which is a byproduct of gas making. So from the 1850s onwards, these lightweight coke elements were available for almost nothing, and they made a very good insulating lightweight concrete. And not only was it used for structural walls, but also for bricks. And here's an example. This came from a building which had concrete bricks, and then on the face of it rendered again to look like a a stone finish, but in this case with a reinforcement to hold the rendering on tightly of wire mesh. This coke breeze material was also used for reinforced concrete, but not for very long. The reason is that coke breeze, the product of gas making, contains a lot of sulphur waste in it, and the sulphur tends to corrode the reinforcement. So it's not good for reinforced concrete, but quite good for mass ordinary concrete. Now, in reinforced concrete, of course, you have good quality concrete and you have rods of steel to take the stress at the appropriate points. And this is a very small piece of that. You can see where the steel has come out. And this is important because this came from a very important building, the Jenny's Lascelles Austin wool store in Geelong, now demolished, a really major piece of engineering work in world terms. But its problem was that the reinforcement didn't have enough cover. You have to have enough thickness of concrete over the reinforcement to stop it being water penetrating and the reinforcement rusting. And also, in this case, the quality of the concrete was questionable. And there were sea breezes coming in, so salt came in. So you can see here the reinforcement is not bonded properly with the concrete. Ideally, you get a firm fix between the concrete and the iron. In the 20th century, systems were devised for building in concrete, not necessarily reinforced at all, but building in units of concrete. And this is one of the most famous of them. This piece here is Nitlock, patented by the architect Walter Burley Griffin, the American architect who came to Australia, patented in 1917. And what you're seeing here is two units which slot together. The ribs make them join together, so that both are cast with a perfectly good flat face, but then you put them together to create a wall. Now these are called the tesseral units, and in the wall you have the whole wall built in a quite thin dimension of tesseral units, but at intervals vertical ribs called vertebral units, vertebral like a spine, which give the strength to the wall, and that's the basis of Griffin's patent. On the face of the wall in the 20th century, you might, in the arts and craft tradition, try and make it look cottagey by having a finish like this. This is rough cast. So it has perfectly ordinary cement render first, and on the face of it, this finish, which has small stones and has been thrown against the wall to give a sort of rustic effect. Now from there we should turn to the internal plastering finishes. Commonly inside plaster would be plastered over laths, not lathes, but laths. These are ideally split timber. Split timber is better than sawn timber because it has a better bond to the plaster, but sawn timber was sometimes used. So these are placed over the whole framework in the wall with smaller gaps between. The plaster is plastered over and it forces its way into the grooves between and therefore holds onto the wall. And that's the standard way of plastering right into the 20th century. However, there were various substitutes, and this is one. This is called expanded metal. Expanded metal achieves the same effect. The plaster can be pushed through it and therefore would bond. Now, it's called expanded because it's made from a single sheet of metal which has a number of little slots punched in it and then pulled out sideways to create a diamond pattern which makes this very useful mesh. The same material came to be used even for some forms of reinforced concrete, although originally it was devised for plastering. Now the finished plaster may be common gypsum plaster, but at some points where there's elaborate decorative work or where there's corners that might be damaged by passing traffic, keen cement is used. Now keen cement, although it's called cement, is a form of hard plaster. And there's another one, Martin's or Perrion cement, used for the same purposes. Skirtings, for example, which you may think are going to be timber, often proves to be this hard plaster or so-called cement. This is an example of a skirting. It's not keen cement, it's ordinary sort of concrete cement, but you can see how the wall has a line of plaster which is the surface of the wall proper, and then the cement skirting's been put on the face and run by a plasterer to give an effect which, when you look at it, you might assume was timber, but of course it's not. And then the same way, for mouldings like this, you may need to again use keen cement to get greater strength. These are quite difficult to make, and I can't describe it in detail here. They have undercuts, which means you tend to make them in a silica gel mould, which can then be peeled off to get that complicated shape.